Hey everyone, welcome to my channel. Today we are creating this exciting AI typing tutor which will allow us to correct our finger typing. A lot of us, we don't use the correct fingers when we are typing. So this AI will tell you, this AI algorithm will tell you whether you are using the correct finger with the correct key or not. So let me give you a demo. So this is basically our detection. So here you can see when I put both my hands here, they started tracking, and now I can track where my fingers are. And using this, we can you can see it is a detection solid if both hands are tracking. If it's only one, it shows detection is weak. So here, if I press the Y button, it shows green because I use the index finger to press it. Now here it's showing S. Let me press it with the wrong one, and here you can see it says wrong. Now if I press it with the correct one, it says correct. So let me bring it down here so you can see which fingers I'm using. This will be a little bit difficult. So here it is U. So here I'm pressing it with the correct one, so it will become green. Here it is showing K. This is the K. If I press it, it shows correct. Now for the W, let me use the wrong finger. So here I will use my index, the middle finger, and it's showed that it is wrong. So let me try it again. So if I press the W with the correct one, it accepts it. So now for the T, let me use the wrong one. So this one I'm using here for the T, it shows wrong. But if I use the correct one, it shows T is correct. And then again for the G, let me use the wrong one. It shows wrong. And if I use the correct one, it shows correct. So this is basically our AI typing tutor. Most websites, they don't really tell you if you're typing with the correct finger or not. This will allow you to type with the correct fingers. So we will learn all of this and more. So stay tuned. This video is sponsored by ClearML. Do you want to know how machine learning and computer vision are done in the industry? Well, we all love running experiments and notebooks to learn really fast. But when solving problems in the real world, things tend to get really complicated. But that just means there's more to learn. ClearML, an open source toolbox, will help you bridge the gap between learning and actually deploying your projects in a way that's scalable to thousands of users. If you love machine learning and are looking to make real impact with your skills, you can get started for free in 10 minutes. Check out ClearML and let them help you take your projects to the next level. If you would like to level up your computer vision skills, do check out our premium courses that are available on our CV Zone platform. Links are in the description. So without further ado, let's get started. So before we begin the projects, let's go ahead and discuss the idea behind it. So this is inspired by a project by the name Bright Fingers. So this was launched quite a while back, about maybe 8-9 years ago. And what they came up with was a solution that when you are typing, you should be able to know which fingers to use when you're typing. So normally if you go to, for example, 10 Fast Fingers or KeyBR, they will tell you that these are the keys that you pressed, but it will not tell you whether you use the correct finger to press it or not. And me including, I have been guilty of this. So a lot of times we don't use the correct fingers, and in the long term, this actually can be problematic. So it is good to start with the correct posture, with the correct positions, with the correct fingers. So specifically for youngsters, for kids who are starting to learn typing, this will be very useful. So that's what they have displayed here as well. So you can see this kid here, she is actually wearing some gloves, and using these gloves, they are detecting which fingers are pressing which keys. And as you can see, they also have a device up top here on the laptop itself. So we are going to create that as well. You could use a normal webcam as well. I believe I have it somewhere here. So you can use a normal webcam like this, and you can actually bend it and put it on top of the laptop. So it is pointing downwards and it is looking at the keyboard. But in this case, if you use a device, a 3D printed device with a mirror on it, it makes it very easy and robust, and it doesn't really move a lot. So the repeatability of it is quite useful. So we are going to design and 3D print this, and moving on, you can see here that each finger corresponds to some color. So for example, the blue one here is for T, G, B, V, F, and R. And then for the yellow, we have E, W, S, and I believe X is at the bottom here. And the same thing goes over here. So what we are going to do different here is that we will not use a glove. We will use AI instead. Using the MediaPipe package, we are going to detect our fingers without wearing any glove, and we will try to replicate what they have done, but with a more advanced algorithm, with a more advanced approach. So hopefully this will give us some good results. And of course, you can make a game out of it later on, and you can create lots of different types of interactive experiences, which can actually encourage and enhance the typing experience for, especially for youngsters. So let's go ahead, and you can see here that I have created this project in our PyCharm IDE, and it is called AI Typing Tutor. So it comes up with a main.py file. We are going to delete everything. By the way, I'm using a Mac today for doing this because, as I mentioned, as you can see, this is the device that we have printed, 3D printed. I designed it on Fusion 360, and there is a mirror at the back, and you can see using this mirror we can see the keyboard. And a similar thing we did in the Tello programming course, where we wanted to see the line that is below the Tello drone. So we had a mirror which we used on the Tello drone, which actually showed us what was down right below the Tello drone. Now, one thing that I had to play around with was the angle. At which angle do you keep so that you get the keyboard viewing angle, you get some good results. So I found, I believe 30, 35, something like that. I can't remember. I did it a few days back. So I will add that in the description, the angle, and I will also add this file, and you can download it from our website CV Zone, and you can check it out there. So all the files will be there along with the code. All you have to do is sign in and you can download this. And by the way, it took only, I believe, 30 minutes to print this. So it is quite sturdy and it is quite easy to print. So let's go ahead. I will just tuck it in and we will start with the programming part. So let's go ahead. So the first thing we need to do, we need to install, we'll go to PyCharm. So this is Mac. So you have to click on PyCharm, Preferences, and then over here you will go to the project, AI Typing Tutor, and then you will go to the interpreter, and we do not have an interpreter. That's very sad. So we'll click on Add, and over here we already have an environment. We are going to say, oh, wait, do we have an environment? Yeah, we have a virtual environment. And this is using Python 3.7.6. That is a very stable version, which I highly recommend. But if you want to use something later on as well, that's fine too. Okay, so then we are going to go and add MediaPipe. Why is it not showing? Okay, there you go. So we added MediaPipe, and then we will use CV Zone, which is basically a wrapper for it, which makes it easier. Within a few lines of code, like 2-3 lines, you can actually use MediaPipe, and you don't have to change a lot of things. So meanwhile it is installing, let me show you what we are going to build. So I have created this graphics of background.png, and let me import it here. So this is our image. So this is what we are going to do at the end of the day, like really at the end, when we are finishing the project, we are going to use this image to actually display all the numbers here, all the values, and then we are going to have a key which will be the one that you have to press. So if you press that key and you press it with the correct finger, then it will put it to correct one. If you press it but with the wrong finger, then it will put it as 0. It will add to the wrong count. So it will tell you how many times did you press wrong, how many times did you press the correct with the correct finger. And we also need, I forgot, we need Pygame as well. So let's go ahead and install Pygame as well. So we are going to go to add, and we will write here Pygame. Now the reason we need Pygame is to detect the key press. Now you could do this with Opencv as well, and I tried it, but it did not work well. So there were some delays. Sometimes it doesn't work properly. So it's worthwhile if you switch it to Pygame, and we can create it. We have done a complete project on this. We have a complete course on Pygame and Opencv, how to integrate it, how to make games out of it, how to make an executable file at the end so you can distribute it, sell it, whatever you want. So if you have taken that course, this will be very easy for you. But if you didn't purchase the paid course, don't worry. We also have a 2 or 3 hour course that actually teaches you the basics. So even if you go through that, I think this should be pretty much easy for you to work with. Okay, so now that we have everything ready, let's go ahead and import cv2 and import numpy as np. And then we also need, okay, let's just keep it simple. We'll go step by step. This is a long project, so we will go step by step so we don't get confused. So now we are going to create our capture object for the webcam. So let's go ahead and do that. Cap equals cv2.video capture, and we need the device number 0, cap.sets. Now, if you're using it on a non-Mac or you're using it somewhere else, then I would recommend that you add this so that the resolution is the same. So by default, a lot of cameras, they use 640 by 480. So to counter that, we need to add this line. So number 4 is height and number 3 is the width. We need it as 1280 and 720. So this is pretty much what we do for every other project. So we'll write while true, and we will write that the success and the image equal cap.read, and that is what we need. Wait, that rhymes. Okay, we'll write cv2.imshow, and then we will write image and img, and then we will write cv2.wait key, and we'll put 1. So this part here is for Opencv by itself. Now later on, we are going to learn how to integrate it with Opencv and Pygame so that we run it properly. Okay, so let's run that. Did it work? It takes a while to actually start, especially if you're recording with it. It will take a little bit. Okay, there you go. So here you can see my webcam. So if I remove this device, you will see me. And if I put it back on, you will see the actual keyboard. So this is great because it has a wide angle view. It should cover the complete region. So what we are trying to find is these points. So this, and the point still here. So we don't really care about the one at the top. You could care about it. You could add it. But for this case, I ignored it because we just want alphabets. If you want numerical, then you can do that too. So we are going to crop out this region. So this will be our first task. We want to crop out all of this region, and we are going to hard code these values that, okay, this is point X, point 1, this is point 2, this is point 3, this is point 4, and using that, give us a cropped image. But cropping itself is not enough because this is not a correct view to actually find the detections. So what we are going to do instead is we are going to warp the image. So warping will give us a bird's eye view, which will allow us to get better detections to find whether we pressed on the key or not. So that's the basic idea. Okay, so as I mentioned, the next thing will be to warp. So let's go ahead and warp our keyboard. So let me check the values here. So we are going to create some initial warping points. Now I tested this before. So these points I'm going to copy, but of course it might not be exactly the same. So we are going to play around with those. So initial warping points, these are basically, this is the origin point 0, 0. This is the width and 0. This is the 0 and height, and this is the width and height. So this is what defines our initial warping points. And then what we have to do is we have to create 2 points for our warping. So the first point is basically we are simply converting it into a format that will be used by the this NumPy library. So we have to do that. And then the second one is basically what I defined here is the 0, 0. We are saying that this value here is basically corresponding to 0, 0. This value here is basically width and 0, and so on. So this is the height, 0 and height, and this is the width and height. But as you can see, we did not define the width and the height. So that is what we should do here. So we will write here width equals 1280, and the height equals 720. So that's the idea. And then instead of using hard-coded values, we can just put this over here. Okay, so this will give us 2 points. So I'm going through this a little bit fast because warping is not something very complicated. We have done this in tons of projects before, so that's why we are skipping through it a little bit faster than usual. So we have points 1 and we have points 2, but when we are in the loop, we are actually going to use to warp them. So to warp it, all we need is a simple matrix, and after that matrix we are using the warp perspective command. So here we will write the matrix equals cv2 dot get perspective transform, and we will give in the points 1 and we will give in the points 2. So now this will create a matrix for the transformation, and now all we have to do is to create our warp perspective. So here we are going to write our image outputs, or should we write warped? Let's say image warp. Image warp is cv2 dot warp perspective, and then we have to give in the image, then we have to give in the matrix, and then we have to give in the width and the height. So the width and the height. And now all we can do is we can display this. So here we will write image warp, and we will write here image warp. So let's go ahead and run that. There you go. So this is the image warp, but as you can see, it is quite bloated. So what we need to do is we need to define the width and height. It should not be the same as the actual width and height of the image. So what is it based on? It is based on the actual measurements. So when I didn't check it online, I measured it myself. So the width and the height of, let's just, oh, what happened there? So we'll copy this and we are going to write here width of keyboard and the height of keyboard. So the width and height of keyboard, what exactly is that? So the width, when I measured it, it was 275. So this was in mm. So what you can do is 275 in pixels will be very small. So what we can do is we'll multiply it with the scale value. So we'll write here scale, and we will write scale equals, let's say 4. Okay, and the same thing we'll do with the height. So the height, when I measured it, it was 72, and we will multiply it again with the scale. So now we will use the width of the keyboard and the width of the height of the keyboard. What is happening? Okay, so that is good, and we have to do that here as well. Width of the keyboard and height of the keyboard, and then we will do it over here. So this will be width of the keyboard. Okay, so let's run this and see if we get good results. There you go. So now you can see this is our original image, and now we are getting a decent image that actually looks like a keyboard. So we are headed in the correct direction, but as you can see, the points are not correct. So what we can do is, first of all, we can display the points. So we'll write here for points, for point in warp points. Wait, we didn't declare warp points. What did we write it as? initial word points. Okay, initial word points, and then we are going to write cv2 dot circle, and we'll give in the image, we will give in the center as the point value, radius, let's keep it at 5, color, let's put it red, so bgr, so it will be 255, and then thickness, let's say cv2 dot fill. There you go. So let's run that and see if we are getting the correct points. Okay, there you go. So these are the points, and as you can see clearly they are not in the correct position. So there are two things you can do here. The first one is that you can move these up and down based on random values. So for example, I can go up here and I can see 33 is not enough, so I can put, let's say, 37, and then I can press play. So this way I can check for each one of these X and Y, and then I can repeat it, which you can see is not a very good process. It's very manual and it will take a lot of time. So what's the alternative? The alternative is very simple. What we will do is we will check if it is our first frame, we are going to save the image. So here we are going to declare some variables. Let's just put here variables, and we are going to say is first frame equals true. So what is this first frame? Okay, so if it's the first frame, then we are going to save this image. So if is first frame, then cv2 dot I am right, and the file name, let's call it sample.jpg, and then we are going to give in our image. So let's run that. So now it's taken the image, and if we look here, this is our sample.jpg. Now using this image, we can open up any software that will allow us to see the pixel values. So I will right click here. In Mac, it's easy to do. In Windows, you can use Paint, and in Mac, you can use the preview. So here we are going to double click it. So it will open up in the preview. And what we will do is we will go up here and we will start from the 0, 0 position. And then we will move to our point where we need to put our 0, 0. So for example, here I can see it is 37 and 271. So I'll go back here and I will write 37, 271. So let's run that and see if it works. If the first one works, we can do the rest of the three together. There you go. So we put it exactly where we wanted. So that's pretty good. And let's go to the second one. So here we will do the same thing. We will start from 0, 0. Let's go back a little bit. We'll start from 0, 0. And over here, this is our point. So 1192 and 254. 1192 and 254. And then let's go to the next one. Over here, which is 134 and 481. 134 and 481. This was way off. Okay, and then we are going to add another point here. 1107 and 468. 1107 and 468. Now you could do this automatically as well. You can detect the keyboard, you can find the areas, the keys and all that. But in this project, we're not going to go into that much detail. It will be complicated and it might not be that reliable. So there you go. So we have our image and you can see the right one is not correct. So the width needs to be a little bit higher. So here 0, 0 this, and then this is the width. So maybe a little bit more, 97, let's say. So right now I'm just eyeballing it or assuming. Yeah, now it's much better. So now it looks straight. and we are at the edges and everything looks good. So what is the next step? The next step is to flip it, because right now the image is it's not correct for us to view the X and Y and all these positions. So what we are going to do is we are going to simply flip our output. So here we are going to write that our image verb equals cv2 dot flip, come on, flip, and then we are going to flip our image verb, and the direction is, the flip code is horizontal, it's not vertical. So that's what we are mentioning here, that this is horizontal flip, not a vertical flip. So let's open that up, and there you go. So now we have, oh, I moved it a little bit. So this is one point, another point, that when you are using it, you should keep it at a consistent angle. So don't move your screen again and again, which I just did, which I should not have done. So this here, but even if you do, you can easily come back. So here you can check out the points, or you can check out the image verb. So by just moving the angle, you will find the perfect position where everything lines up automatically. So you don't have to worry too much about that. So here you can see pretty much, I think this is the correct position. So here you can see we are getting everything back again. So that's good. Now we have the image verb, and now what we can do is, using the layout, we already know the X and Y positions of all these values. So we know where the Q is, we know where the W is, we know where the E is, R is, and all that. So what I have done is, I went through manually one by one, I checked out all the dimensions, and what you could do is you could put a for loop, and you can say, okay, for example, one key is the size of 50 by 50. So, and there is a gap of, let's say, 20 pixels. So keep looping and adding a box for each key. So what we are trying to do is we are trying to find the locations of these keys. So you could do that, but in reality, it doesn't work well. So because there's some noise, some warping is not perfect. So when the error is small in the beginning, when you use a for loop, it accumulates and becomes really big at the end. So the last few keys will be far off. So it's not a very good way to do it. So what's the other way to do it? It's simple, but it takes time, and I have done it, so I'm not going to repeat it. What we will do is we will create a dictionary. And in this dictionary, we are going to define, first of all, the key as the alphabet. So for example, we have Q, we have W, we have E, and all that. There will be 26 in total, because that's how many alphabets we have. Then the second aspect will be the bounding box information. So where is this in the verb image? So at what pixel value is the bounding box? That will be the second information. The third info is going to be which finger is the correct finger to press this key with. So for example, if we go to our bright fingers, they have actually shown us here. The index finger is responsible, and not just the index finger, the left index finger is responsible for R, F, V, T, G, and B. So what we will define it as right index. For the left index, sorry, this was a left. So for the right index, we are going to define Y, H, N, and all that. So we need to define for each one of these. So I have already done that. And what I will do is I will paste it here. And here you can see this is a dictionary. So it is called key locations. So all of the keys, where are their locations? So this is the first row, which contains Q, W, E, R, and all that. And you can see Q is at 28, 0, 16, and 15. So 28 and 0 is the width and the, is the X and the Y value. And this, it's width and height. So 16 and 15. And here it's telling us that the left pinky is supposed to click the Q key. W is supposed to be by the left ring. E is supposed to be by the left middle. and all that. So here you can see this is the complete first row. This is the second row where you have A, S, D, F, and all that. And this is the third row where you have Z, X, C, V, B, N, M, all that. So this is our dictionary. Now to check whether we are headed in the right direction, whether these values are correct or wrong, what we can do is we can draw it. Simple as that. So what we will do is we will go down, and on the verb image we are going to draw. So here we are going to write draw, and what are we drawing? We are drawing the bounding boxes. For bounding box I will write BBOX, so bounding box. For the bounding box we are going to draw on the verb image. Okay, so we will say for key and value. So that's how you address a dictionary. You have key, you have value. So for key and value, why did I write it so wrong? For key and value, in our key locations dot items. So when you're using dictionary, you cannot just use like a list. You have to write dot items. That's just something that is by default. You have to do this. Anyways, so what we will do is we are going to create a rectangle. So we'll write cv2 dot rectangle. We want to put it on our image. Our point one is basically what do we write? Okay, so for the point we need x, y, width and height, which is equal to the value at number. So this one is 0, 1, 2 and 3. So this one, value at 0, value at 1, value at 2 and value at 3. Okay, so then we can simply write x and y is our first point, and then x plus width and then y plus height is our second point. This should be a bracket. There you go. And then what do we need? We need the color. Let's put it as purple because I like it. And then we will put the thickness as, let's say, 2. And I believe that should be enough. So let's go ahead and run it. Wait, what? Oh, it should be image verb. So let's see if it works correctly. What is happening? Oh, okay. So this positioning, the positioning that I've written here is based on actual mm. So this is actual dimensions. So 28 mm from the width, the starting width. So it is not really scaled. So you have to scale it by the value that we are using. So we have to write scale multiplied by scale. There you go. Again, all of this will be available on our website. So instead of just writing it down, just copy it from the code, but don't copy the complete code. Do it step by step. That will make it quite easy for you to learn. There you go. Perfect. Well, not perfect, but it is very close. I would say this is very good. So if I move the screen, you can say it gets off. But again, as I mentioned, it's very easy. You just move it back, and at some point it's going to align by itself. So you need to find that point and you need to stop, and it's very simple. So there you go. So now we are at the correct positions and we know the location of all of these keys. So what we need to do is we need to check if one of these keys was pressed, and then we will check if when the key was pressed, where was our finger. So all of the fingers, by the way, we need to check all of the fingers where they were, and we will check if that finger from which we pressed, is it the correct one or not. Again, it's a lot to take in one step. So what we'll do is we'll break it down into different steps. So what should we do after this? So what we can do is we can check for the key presses, or we can check if the finger is in the correct position. Let's do the key press first. So for the key press, we need Pygame. So we will import Pygame. And when you import Pygame, you have to initialize it. So we will write pygame.init. So that will initialize the Pygame. And we have some default parameters that we have to use with Pygame. I will show you and explain what they are. Again, if you want to learn more about it, check out our game development computer vision course. It will tell you in detail what exactly are we doing and why are we doing it. So let me copy it here, and let's bring the PyInit here as well. So everything related to Pygame, we will put it down over here. Okay, so we are initializing Pygame. We are creating a window or a display for Pygame. Okay, so now earlier we were using Opencv to display, but now if you want to check the key press, you have to use Pygame window. There is no other option. So we will keep it the same, the width and the height. So we already have that. We will remove this. Then we are creating a window. We are calling it my awesome game. We can write here AI tutor typing tutor. Okay, and then we have to initialize the clock. We will keep it at 30 frames per second because we are going to use media pipe library, which pretty much runs at 30 frames per second on the CPU. And yeah, that's pretty much what we have to do for initializing. And then in the update, we have to add something as well. For the updates, you have to add, update display and clock.tick. So it will tick the clock and it will update the Pygame display. But we are not actually showing the Pygame display. So to display that using Opencv, we have our own code. Wait, let's bring that back. What is happening? There you go. So here we have the Opencv display code. So when you want to display the Opencv webcam on the Pygame window, this is what you do. Let me explain what is happening. So we take this image and we convert it into RGB instead of BGR. Because Pygame uses RGB, Opencv uses BGR. So we need to convert it. And then we will use NumPy to rotate the image. So if you don't do that, it will be vertical. So it's not good. And then we have to use Pygame .make surface to actually convert the image from Opencv to Pygame. And then we have to flip it again so that it is in the correct orientation. And then to display it on the window, we have to use window.blitz. And we are saying that add this image at the location 00. So that's the basic idea. So let's run that and let's see if we are getting our Opencv window integrated in the Pygame window. So nothing is happening so far. Let's wait for it to run. So Pygame is running, that's good. And where is it? There you go, AI typing tutor. So here you can see it's pretty much the same image. So nothing special here. It's just we are using the Opencv image to overlay on the Pygame window. So that's pretty good. Now, whenever we press a key, we should be able to detect it using Pygame. So how do we do that? So we'll go to while true, and at the very top, we are going to add an event listener. So the event listener is going to listen to the events from the Pygame. So we are going to write here for event in Pygame dot event dot get. So this will give us all the events. Now we need to check the type of event that we need. So for the type of event, we need key down. So we will say that if event dot type equals Pygame dot key down, if a key was pressed, then we will check which key was pressed. So to check that, we have to ask for the very specific key. So for example, we will write if our event dot key equals, let's say, q, then let me write it here, then print q key was pressed. But there's a twist. You cannot just simply write it like this, q. What you have to write is pygame dot key underscore, sorry, k underscore, whatever the key is. So for example, here it's q, so we'll write it like this, q. So let's run that, and whenever we press the q button, it should give us that. So we'll go back, and this is our AI typing tutor. So let's put it on the side, and I'm going to press the q button. So this is our q button, and when I press it, nothing happens. Excellent. Let me try it again. Okay, nothing is happening. Oh, now it detected. Why is that? It's a lot of... Oh, there is a heavy delay. And that is a very excellent point, and I'm glad that we had this issue, because I was stuck at this for a while. And the reason is you need to remove the wait key. So you cannot use the wait key anymore, so you have to remove that, because that is actually creating this problem. So if we go back and we go to the image and AI typing tutor, oh, what happened there? AI typing tutor, let me press the Q, and there you go. So whenever I press, now it is detecting the Q press. And if I press something else, nothing is going to happen. So you have to make sure which key you are checking, which key you are pressing, and based on that, you can check if it's working or not. Okay. So far it's good. We are checking the key as well. Now, what we need to do is we need to bring in our background image. And what we will do is we are going to display it on our main image. So we don't really need this frame to be our original webcam image. What we need is the background image. So what we will do is we will add that, and we have to do it in the loop. It's not the best way to do it. It's not the most efficient, but because we have to update the values, we have to draw different things on the image, we have to keep importing it again and again. Otherwise, it will overlay the previous detections and this detection, and it will be messy. So here we will write cv2.imRead. And what are we reading? We are simply reading the background.png, and we will store it in image background. So we are going to copy that. Why is it giving an error? The indentation is wrong. That's why. Okay, we will copy that and we will paste it to our what do you call, pygame window. So we don't really need to show the webcam image. So there you go. So this is our AI typing tutor, and now we have our what do you call, main game image that we are going to use. Now what we need to do is we need to know the location of this background image as well. So the key locations of this background image is completely different than what we have in the key locations right now. So we cannot use that. So I have also written, now in this case, I wrote a simple for loop because it is a predefined image. It's created with a digital software. So that's why we don't need to worry about that. So let me copy that. Copy the code to actually write the for loop. So here we are writing that we are creating a dictionary for positions of the keys in the background image. Yeah, I think that's pretty accurate. So once we have that, let's paste it. So again, we have rows. So each row has Q, W, E, R, all of the alphabets that is for that particular row. And then where is the row starting? So this is the value of where the row starts, because if you look at the image here, the background image, the first row is starting from here. The second one is starting from here. The third one is starting from here. So the width of all three of them are different. So that's what we need to know. So this is a list which tells us which are the starting points. And then this is the key location for drawing. Or should we name it something else? Key location draw. Key locations background. Let's write it like that because it is for the background image. So we will write key locations background. So key locations for the background, and here this is the value that is consistent between the gap between each starting point, the width, and this is the consistent gap between each width. So we multiply it with J and I because we are looping for the row and then we are looping with the column. And this is the width and the height of each one of these, and it is same for all of them because again it's a digital image, we actually created it, there are no noise and no problems with this image. So all we need to do now is to draw. So before we send it to Pygame, we are going to draw. So here we are going to write draw on the main, or let's say background image. Draw on the background image. So what we will draw any key that was pressed. Or should we do that, or should we not do that? What we can do, okay, we'll do one thing. We will create here, we added something called the variables. Yeah, here we are going to write, let's call it current key. So this will be the current key of the game that needs to be pressed. So let's say the current key is Y. So we will start off with Y. You can put a random value here as well with the generator. So it can generate a random value, but for now we'll just keep it Y. So then we are going to check if our key Y is pressed, then we are going to light up the area of Y. So how can we do that? We will write here cb2 dot rectangle, and we have done similar thing here. We'll copy that, we'll paste it here because we are very lazy, and then we'll write here image background, and then we need the XY values. So the XY values, they will come basically from without the scale. We don't need, do we need the scale? I don't think so. Yeah, we don't need the scale. So this is a digital image, so we don't need that. Remove, and for this, for the dictionary, we are only using it locations background at 0. Yeah, so you can simply write value. And that should give us the X, Y, width and height. So that is good, but which one are we talking about? So we need to draw on that one and on that particular key. So our current key, whatever it is, so we will write that the value current equals, so we will take it from our dictionary, which is key locations background, and from key locations background we want the key to be current key. Okay, I hope that makes sense. And here we will write value current. So this is purple. Let's make it green. And let's make it filled. Let's run that. So yeah, there you go. So the current key is being placed, and you can see there's a green rectangle around it. So that's good, but we want to show the green color only when the key is pressed. So that's what we are going to do here. So here, if the event is this, then the key was pressed. We are going to write here a variable, current key pressed equals false. And here we are going to write, if that happens, current key pressed equals true. Okay, so there will be some issues with that. I will tell you what they are later on, but what we need to check is yeah, we need to write else current key pressed is false. So now here we are checking for Q, but we don't want to check for Q. We want to check for the current key. We are not simply checking, hard coding the value here Q. But the problem here is, how do you write it like this? K underscore Q. You cannot write a string and you can not put it with a dot here, right? So how can you write this with the dynamic value just over here? So there is a simple function for that, and that function is basically like this. So it will check my key equals get attribute, and then we are going to write pygame. So this is our first part, and then after the dot we have k underscore q. So we will write the second part. So here we will write k underscore, and over here we need a dynamic value. So we are saying this is our dynamic value, and this dynamic value will be format, and it will be current key. So that's the idea. So once we have our key, we can simply paste it here, and it will check if our current key was pressed or not. So here even we can write current key. It automatically makes it an F string if we add these curly brackets. So then it will write current key was pressed. So when that happens, then we are going to draw. So here we will write if current key pressed, then you do all of that. There you go. So if I press, what was the key? Y. There you go. If I press Y, it makes it green, and then it doesn't go back. Why is that? Why doesn't it go back? Current key pressed equals false. If event key dot my key is this is true and this is false, maybe we can push it back. Now it doesn't work at all. Okay, so yeah, because it will have a lot of them when the key is not down. So if my key is pressed, let's just remove this and see if it is working, and then we can go back to the so here, yeah, Y key was pressed. That's good. So what we can do, if current key was pressed, is this, and we are refreshing it every frame. Yes, that is true. I think the current key pressed, we need to put it as false, but in what circumstance do we put it as false? So this we can do, we can put the current key pressed false by default here. Current key pressed equals false. Let's try that. There you go. So once you press, it makes it green, and then it goes back to its original state. So that's good. Now, one more thing we have to do is to make it a bit more appealing, we have to show all the alphabets. So we need to draw all these alphabets on our background image. So the code for that is very simple. You have to loop through all the values and then you have to put it on top of that. So here, draw on the background image. Let's do it after that. So here we will write draw all the alphabets on the background image. So here we will write image. Wait, what is this? No, this is not the right one. Okay, so I was copying the wrong parts. Let's just paste it here. There you go. So this is key locations for the background. So it is looping through all of them. It's getting the X, Y, width and height, and then it's putting on the background image the key value, and it is pushing it a little bit further, and we are giving it a color of white and the thickness of 2. So if we run that, there you go. So you have Q, W, E, R, T and all of that. So that is good. Now we need to show the current key over here. So what exactly is our current key? So again, we can simply put our text. So this is what we have done earlier as well. So here we can put text on our image background, the current key, and this is the location, this is the font, this is the color, the thickness and the scale. So let's run that. And there you go. So now you have our key Y. So we can press the key Y and you can see it becomes green and it looks nice. So that's the basic idea behind this. Now this is good. All of this is good so far. But the main aspect of the project we haven't started yet, which is when we detect the fingers, we check which finger did we use to press that key. If it's the correct one, then it's okay, show a green. But if it's a wrong one, then we need to move on and try it again. So we will go up here, and to detect the fingers, we need the MediaPy package and we need the CVZone library. So we are going to write here from CVZone dot hand tracking module import hand detector. This will give us the detector, and then we are going to create it. So here we will write our detector equals hand detector minimum detection confidence minimum, or let's say detection confidence is, let's say 0.4. We want it to be very lenient, and maximum number of hands should be 2, so we should not exceed that. So before we actually continue, we have to find the hands, and we need to find it on the original image. We cannot do it on all of these warped images. We have to, because the warped image has a very small height, it will be tough to find the hand on it. So we will do it on our original image. So here we are going to write hands, and the image equals, and not a hand, detector dot find hands, and we will give in our image. So this will automatically draw on it. So let's run that and see if we detect our hands. There you go. So if I bring in both my hands, you can see they are detected properly. Let me bring that down. Okay, so here you can see sometimes you have to start like this. You have to put your fingers on the keyboard, and then it starts well and then it types well. But sometimes if you start directly, it might not detect it. You see, one of them is not detecting, one is detecting, so it might get difficult. So if that is the case, just put both of your fingers, both of your hands down, and then you can start typing. So in order to check whether our detection is good or not, what we can do is we can add a feedback. So here in the feedback, what we can do is we can check if hands are detected, then we will make a decision. So here we are going to write if hands, if there is something available in the hands, then we are going to check whether it's 2 hands or 1 hand. So if length of hands equals 2, then it is a good detection. So for good detection, we have some text. So let's copy that. So cv2.put text, we will write detection solid, and we will put it at 50-50. We will give in the font, we'll give in the scale, the color, and the thickness. And the same thing we will do again. We'll write else, and we will paste it, and we will write that if that is not the case, then make it red, make this 0 and make this red, and write detection weak, let's say. So let's run that and see if it works. So here it says, so if you don't add anything, then there is no feedback. If I put 1 hand, it says detection is weak. If I put both hands, it says detection is solid. Let me show you here. There you go. If I put 1 hand, it says detection weak. If I put both hands, it says detection solid. There you go. So whenever you have detection solid, then you should keep playing the game. Otherwise, you should put your hands again on the keyboard laid out so that it detects it properly. So that's the basic idea. Now, once we have the hands, what we need to do is we need to loop through these hands, and we need to check whether it's left or right. So if it's left, then we are going to create a text, and that text, whether it's left or right, doesn't matter. We will create that text and we will compare it with this text, left pinky, for example. So first of all, we will have to check whether it's left or right. If it's left and you are using pinky and the button is pressed, then we will say, okay, that is 1 correct. If the button is pressed, but you are using, instead of left, you are using right, or instead of pinky, you are using ring, then it will give you wrong. So it will give 1 in the wrong values. Okay, so how can we do that? We'll go down here, and then when the hands are detected, then we are going to check for the location of our fingers. Now, we are first of all going to loop through for hand in hands. So we are going to loop through all the hands. And first of all, we need the hand type. Hand type equals hand, and it's a dictionary, so we will write type. So this hand type is going to give us, so we can just print it, print hand type. Now the problem is it will display us something that we don't want. So if I bring in my hand, you can see it shows left and right with a capital R and a capital L. And for this dictionary, we are using small l and small r. So they are not capital. So what we can do is we can simply write dot lower. So that is going to lower the values so that we can have exactly the same that we had before. So if I run it again, if we go back, you can see now it's left and right, like we have in our dictionary. So that's good. Now we have the first part. So later on, we are going to compare it with this text. So we have the first region. Now we need to know the second region. Which finger is pressed? Which finger are we talking about? Okay. So for this example, for this project, we are only going to use 4 fingers. So we are not going to use the thumb. We will use 4 fingers. If you wanted, you can add the thumb as well. It's up to you. So what we are going to do, we are going to say that if current key pressed, if that is true, then we are going to check, we are going to loop through all the fingers, and we will check if our finger is in that position of our key. So let's say our key is Y. So we need to check which finger is pressing the Y key. We need to check that. So if that key which pressed it is equal to the key that is written here, the finger that is written here, then we will say done, that's correct. So that's how we will do it. Where is it? There you go. It's double S. Pressing the key. Okay, so we can comment this. Which finger is pressing the key? So how can we do that? So first we need the position of our correct key. So we are going to call it key equals current key, and the value of this key is basically we are going to get from our key locations. So we will get it from key locations at the value key. So the key and the value we have. So get the bounding box info of the correct key to check the finger location. Okay, that's good. Then what we will do is we will get the bounding box information. So what is the bounding box information? As you can see here, this is how we can get it. X, Y, width and height is value this, scale value 1, 2, 3 and scale. You have to multiply it by scale to get the correct bounding box information. So this is getting the bounding box info of the correct key. Now we need to check if the finger is actually touching this key or not. But we didn't do anything of the fingers yet. So what we need to do is we need to declare the point numbers for each of these fingertips. So what we are going to write, we are going to write point, or let's say finger IDs equal, we are going to put a dictionary. So for the dictionary, we are going to write for point number 8, the value is index. For point number 12, so this is available from the media pipe package. So this is these keys they have defined. So middle, then we have what do you call, I believe 16. Yeah, 16. And this is ring. And then we have 20. So 20. And then we have oh, I put 2 of these here, my bad. This is the ring. No, not the ring, the pinky. There you go. So for the dictionaries, you have to put commas here. There you go, like that. So that should be good enough. You have 8, 12, 16, 20. So we are going to loop through all the points. So for points in finger IDs, we are going to loop through all of these. So now we need to actually get the X and Y value of this point. So the point itself is just an ID. Actually, let's write it ID. So it is just an ID that is pointing to an XY value. So we need to get that XY value. So here we will write point equals, we are getting the point, the ID number is basically integer of ID, and we are getting it from hands at the LM list at ID. So for example, if I wanted ID number 8, I will write hands LM list 8. So this is what we are doing here. So this will give us the ID or the X and Y value of our actual points. So once we have that, we cannot actually use it, unfortunately, because that image is of the verb, is not of the verb image. That image, that point is coming from this image. So it's this point. You can see this is the index tip. It's giving us this point. But what we need to check is that whether that point is over here or not at W. So it is after the warping. So you know how to warp an image, but how do you warp a point? So to warp a point, you need the matrix. So we already have that. Once you have that matrix, all you need is a function. So that function is very simple. I actually found it on the Stack Overflow, and I am going to simply copy and paste it over here, like all good programmers do, copy and paste from Stack Overflow. So that's the idea. So you give in the points that you want to warp, and then you give in the matrix, and that will give you the output, the pixel value in the correct format. Okay, so where do we need that? We need it here. So we will give in that our point warped equals warp point, and we will give in our point and we will give in our matrix. So that point warped will have the x and y value, so that we will use to actually get to check whether we have pressed, whether we are within our key region or not. So actually we can write it as point x and point y. And one more thing, the problem over here is that we actually flipped our original image. The warp image is actually flipped. So we need to flip the warp point as well. So flipping a warp point is very easy. You write px equals px minus whatever the width is, the width of the keyboard. So that's how simple it is. So once that is done, so let me just write it here. Flip the points. So yeah, that's good. Now we have the x and y point. We have this point. We also have the location of our key. Now we need to check if this point is in this key location, right? So we have the x and y and the width and height, and we have the x and y here. So we need to check whether they are inside each other. That's it. So how do we check that? You will check it by writing a new function. We will call it, or let me just copy it. So we will write here check inside. So here check if fingertip point is in the keyboard key of the bounding box. So this will be our point, which will be px and py, and then x, y, width and height will be the bounding box of the key. So if this point is inside this bounding box, it will give us true. Otherwise, it will give us false. So it's simply returning using an if statement. It's checking if this and this are true, both of them are true, it will return true. Otherwise, it will return false. So here we are going to say that if check inside px and py, and then the x and y we already have all of these, we can simply put it here. So again, I will repeat, this here is for bounding box of key. This here is for tip of the finger. So once you have bounding box key, once you have tip of the finger, you are checking whether they are colliding or not. So that's what we are checking here. If it's inside, then we can simply say, okay, now we have pressed the key. So we can simply print key pressed. Yes, but we need to check it with our correct key. So right now it will give us the value that, okay, this index is inside this, but is it the correct one or not? We don't know. So it's just checking the key press. So how can you check that? You will check if hand type plus underscore plus our finger plus the finger. Wait, why is there no finger? Oh, I made a mistake here. So this is ID, and then we have the finger. So if you remember here, we have the ID and then we have the finger. So it's the key and the value. And because it's a dictionary, we need to write here dot items. So we need to loop through those. So that's the idea. So now this hand type underscore finger is the value that we are getting. Now we need to check whether, why did that happen? Okay, if that is equal to the correct value. So where is the correct value? The correct value is inside the dictionary key locations at this point. So if it's left pinky, we need to compare it with that. So over here, what we can do, where did it go? Where is it? So here in the finger, what we can do is we can write, or let's put it here. Let's put it here that the correct value, correct finger, let's say, equals value at 3. This is still 3. It is at 4. So if you go back here, this is 0, 1, 2, 3, 4. This is the fourth element. So that's the idea. There you go. And you can write here correct finger. So if that is the case, then we can simply print correct. Correct. Otherwise, we can print, else we can print, why is it giving an error? Print wrong. There you go. So let's fix that. Correct. The spelling of correct is wrong, which is ironic. That's good. Okay, let's try it out. Let's see if whatever we have done so far is actually working or not. So here, okay, it's printing something already. We need to remove that. Otherwise, it's difficult to see if it's correct or wrong. Let's try. So let's move it here. Okay, now we can see it. So let me bring in both hands. So it is solid now, the detection. And if I press the Y key, oh, something bad happened. There's an error. The Y key was pressed, which is good. Point hands, LM list, integer ID. List indices must be integers or slices, not string. Interesting. So the mistake I did was I wrote hands. It should be hand, only one. This. So because we are already looping through the hand, so it should be hand at LM list. So that was the mistake. So let's go ahead and try it out again. Let's move all of these on the side. Let's move this here, and I'll bring in my hands, and then I'll press Y, and it says Y key was pressed, but it does not print that it was correct. So okay, so that's not good. Let's see why is that happening. So if I bring it here, seems fine. Seems fine. Okay, so we are checking here that if current key pressed, are we making it true? Current key, yeah, current key pressed is true. Okay, that's good. Then key is current key, value is the value that we get here. For ID and finger, in finger IDs, we are going to check the tip of the finger. We are getting the tip of the finger, and then we are checking inside whether it's inside or not. Okay, we need to break it down to see where the problem is, otherwise we will not be able to find it. So let's check the point, and we can draw it on the warp image. So cv2 dot warp, sorry, cv2 dot circle. Actually, we did it here somewhere. Let's just copy that. Where is the circle? Really? Where did it? Yeah, here. cv2 dot circle, and the point is basically px and py. Px and py, and we want to do it on image warp. So if we go to image warp and we bring in, why is it drawing on the warp image? It should not draw on the warp image. Why is that? We need to warp before we go to the, yeah, this detector hand should be after the warping. Then it will not draw it on that. So it will be easier to see what's going on. There you go. It's not drawing now. So that's good, but it's not showing us the points. So that is a bad sign. So first of all, we need to check where are we reaching the current point or not. So I'm pretty sure we are reaching the current key pressed. So hopefully that's not the problem. Then after that, we need to check if we have reached the inside point, check inside. But before that, it should print this. So maybe we are not reaching here. So let's print this. So what I like to do is I like to write yes. So if we reach that point, then it says yes. So right now, if I bring in both my hands, I press yes. So it says yes. It means when I press it, it is going in that region. So that is good. Then we have the correct finger and the values of X, Y, width, and height. Okay, what we can do is we can draw a rectangle. Okay, so let's take it from here and we can draw it here on the X, Y, width, and height. Let's make it dark green. So now we can see if it's reaching this point and it's detecting those X and Y bounding boxes properly. So let's try that. Yeah, I think I can see. Oh, it's drawing up there. What is that? Oh, sorry, we need to draw it on the warp image, my bad. So if I press Y, yeah, so it is at the correct position. So our bounding box information is correct. So now we need to check which finger is pressing the key. So we have the ID, we have the finger in finger IDs. Point equals hand lm lists, integer ID, px and py. So I guess the problem is somewhere here. So let's print out px and py. So let's see what do we get there. So we are getting px and py in negative. Oh, that's the problem. So it should be, I believe, width of the keyboard minus px. My bad. That is a very small mistake, but has a big effect. Okay, let's try y. Yeah, there you go. So it is showing us the values. There you go. So that is good. Let's stop all the other prints so we can go back to where we were before all of this happened. And now let's see if it says correct or wrong based on if we are using the correct finger or not. So here we are going to move this, move this, move this. We'll press Y. So it's saying it's the wrong finger, which is not correct because it's the correct finger. Oh, is it supposed to be the left? No, it's supposed to be the right. Wait, let me check. So the Y is supposed to be on the right with this, right? So why is that? So hand type. So what we can do is we can print out the hand type and the finger. Let's see, what do we get? So it is saying left index and right index. Oh, I think I know the problem. I think I know the problem. So what we need to do is, let me run this one more time. So this is my right hand, but it is showing it as left. And this is my left hand and it's showing it as right. So that's the problem. So what we need to do is we need to go to the detector, and here we are going to write flip type. Flip type is false. So that will flip the, by default it is flipping, so it will not flip it. So now this is my right hand and it is showing as right hand. So if I go to Y and I press the Y button, let's go ahead here and we press the Y button, it says correct. If I press it with the other one, it says wrong. If I press it with any other, it says wrong. So which is pretty good. So it is telling me which one was pressed and which one was the correct one. So middle right, right index, left index, right index. So when it was correct, right index and right index. So that's how we are checking whether we are pressing the correct one or not. So that's the basic idea. So we are pretty much coming close to the end of our project. Here we have the correct and wrong. Now what we can do is we can write score correct equals plus equals 1, and here we will write score wrong plus equals 1. So here in the variables, where are the variables? We are going to write score correct equals 0 and score wrong equals 0. So, and then we can put these on the display. So score correct and score wrong, wherever we are displaying the other stuff, we can display that as well. So here we draw all alphabets on the background image. So below that we can simply put the text again. On image background, what are we putting? We are putting the string of not the current key, score correct, and the values, the x and y values, let me check. The x and y, 185 and 2, 185 and 245, and the value, the scale is 4, this one is 5. Okay, so let's run that and see if it gives us the correct. Yeah, it's showing us 0. So if I put 1, 2, 3, 4, if I keep pressing, it keeps accepting it as true. Okay, I can copy that and I can paste it here, and we can write here score wrong, and the value for this is 1035, and the rest is pretty much the same. There you go. So if I press Y, it puts it correct. If I use my wrong finger to press Y, it gives us wrong. So if I keep pressing, pressing any other key, it will not do anything. You can add the functionality of that when it's pressed, somebody presses the wrong one, it tells you it's wrong as well. But for now, we are just checking whether the finger pressed, the finger that was used to press, is correct or wrong. So we are assuming you are pressing the correct finger, the correct, what do you call, button. All we are checking is the finger. Okay, so the last thing we need to do is we need to iterate, we need to randomly generate these values. So we will import random, and so what we will do is whenever there is current, the correct one pressed, we are going to replace the current key. So we will write current key equals, we need to generate a random key. So we will write here random dot rand integer, and the value should be from 0 to 25. And we will use this value to actually get one of the values of our dictionary. But as you know, you cannot access the dictionary like this. What you have to do is you have to write list, and you have to convert your dictionary to list. So our dictionary, what was the name? It was key locations. Yeah, key locations. Once you get that, then you get from that list, you get the X value or whatever. So this will give us the key value, and sorry, it will give us the key, not the value. That is what we want, because the keys here, as you can see, the key is Q, W, E, R. That is what we want. So it will randomly generate that, and it will add it here. So let's run that and play. Let's write it down. Y, there you go. It presses S, D, H, and I. What is happening? Why is not H working? So sometimes I think the detection is weak and it doesn't work properly, but sometimes it works well. So let's try again. Y, we, and I'll use the wrong one. There you go, the wrong, it says T. I'll use wrong again. Again, it's wrong. Then I will use T, and then C, again wrong. I need to use the middle finger to do that. Yeah, so if I use the middle finger, it becomes C. So that's the basic idea of how you can do this. Now, if you wanted to add a delay, you can add that too, so that whenever you detect the count, you should wait for a few seconds to actually count again. You can do that too, but I don't believe it is required over here. One more thing we can do is that when we are actually displaying the key press over here, we are giving it a green value all the time. So what we can do is we can remove this code from here, and we can paste it inside the loop. Where did it go? Inside the loop over here. And if it's correct, it should show the color green. If it's wrong, it should show the color red. So we can write here color, and we can put the color as 0255, which is for green. And then for the red, we will put 0 here. So this will differentiate, and now we can simply put the color over here instead of writing a green by default. So if I press the wrong key, it will display the red color. So here, if I press with the wrong, it's showing Y and it's writing it there. But if I do it with the correct one, it shows green and it goes to the next one. So that's our idea. And as I mentioned, we can add a delay as well. So if you wanted to add a delay, it's actually fairly simple. So what we need to do is we need to add a delay counter. So delay, where it is? Okay, so right here, delay count equals 0. So if delay count is 0, then we are going to detect the new presses. Otherwise, we will not. So here, where is it? If hands. So here in the hands, we'll go to our hand, and here we are checking the key press. Now we will add another condition that if the key press, if there is a key press and the count is 0, so the delay count is 0, it means it's the first time it's starting. It means it's a new detection. Then only go ahead and do it. So if it is correct or wrong, doesn't matter. We are going to, if it is inside, we are going to write here delay counter, delay count equals 1. So it will make it 1, and then whenever we see a 1 at the end, we can write here if delay count is not equal to 0, then we will write delay count plus equals 1. And if the delay count is, let's say, greater than or equal to 5, if 5 frames have passed by, then delay count is 0. So then you can do it again, otherwise you cannot. So let's run that. So this will give us some time to actually stabilize the system. So Y, and then G, O, let me use the wrong finger. There you go. N, it shows wrong. And then N here. By the way, what we can do is we can maybe change the color here as well. If you wanted to, like, it will display it here as well, whether you pressed it correct or wrong. So you can add a rectangle over there. So where are we doing this? We are doing it, the green one over here, right? So we can copy this part and we can paste it, and now we need to know the X and Y position of it. So we can go to the background, we can right click, view in Finder, we will open it in preview, and here we can check the value. Let's say we will take this part, and from here till here we are going to what do you call, actually we need to start from here. So let's say from here 505 and 129. So here is 505, 505 and 129, and then we can check the width and height of this box. So the width and the height of this box is what? 285, 177. Let's say 285, this is 285 and 177. So we will add 505 to it. 505, 129, and there you go. So now it will change the main color as well, the main display. Okay, so if I put Y, there you go. Then if I use the wrong one, if I press B, it shows the red color there. And then if I press it with the right one, there you go. Then if I press it with the right, oh, this is the wrong one. Then if I press it again, there you go. So now it uses the correct one. So here I have done 3 correct and 3 wrong. So that's the basic idea. So this was our project for today. I know it was a long project. It was a quite fun project because it is something you can actually use in real life. You can give this to a kid and they can actually learn how to type properly. And even for youngsters or even for adults who are still learning to type, and even for someone like me who does a lot of typing mistakes, and a lot of it is because of I'm using wrong fingers. This will be quite helpful. You can enhance it, advance it, and you can even create an executable file out of this. And all of this, we explain it in our computer vision game development course. So if you like this project, give it a thumbs up, check out our course. And if you loved it, share it with your friends, and I will see you in the next one.